Cool. Thank you again for joining. So as Ricky said, I'm James Brown, Head of Digital Manufacturing at Prodtex, and I'm going to kick off today's session. So before we dive into the webinar, for those of you who don't know who we are, Prodtex is based in Northern Europe, and we specialize in construction, infrastructure, aerospace, and automotive manufacturing. Our prime focus is DELMIA Digital Manufacturing as a license provider, trainer, and expert user and consultant as well, which you'll kind of get a flavor of that today. We also do some work in robotics and tooling design. We always like to throw that in because it shows that we have first-hand experience actually doing the things in factories. We're not just using the software to do it. We think we know what we're talking about at least. Cool. So this is the second in a series of webinars that we're running. So this one's specifically on leveling up offsite prefab construction with digital factory design. So you're going to see some interesting stuff in here, and then there'll be a load of different webinars throughout this series too, which I'll recap at the end. And for those of you who don't know what 3D experience is and have absolutely no idea what we're going to cover in this session, so I always like to start off with an intro to 3DX. So specifically what it's all about is bringing data together into a single place. It's about bringing people together from across a business, so design, marketing, ergonomists, sales, whoever, all in one place. And then it's about giving these people the tools to enable them to use this data and work collaboratively. And the real backbone, like you'll see in Ed's amazing presentation today, it's all about data-driven experience. So there's data behind everything we do. That's kind of a brief intro. And then what we're going to cover specifically in this webinar, so we've created a scenario. So we have this amazing garden studio product that's been designed by Ed in the webinar again today. So we've been challenged to perform a DFMA on this prefab product that's been given to us by the architects and designers, and we need to evaluate the industrial potential of this thing. So we're going to start off with a MBOM, or manufacturing breakdown. We're going to then move on to an industrial process sequencing and 4D build-up. I'm then going to hand over to Ed, who's going to run us through the plant layout and industrial optioneering opportunities. And we'll also cover some industrial rate, bottlenecks, KPIs at the end as well. So yeah, quite an exciting session, I think. So should be good. Cool. So starting with the EBOM. So the most important thing with this is this can take in all forms of data. So this is CATIA, if you're lucky to work with that, SolidWorks, Revit, IFC, Tekla, whatever kind of design data you're using, we'll bring that into the software. Like this is usually coming from a designer, and the tree structure is basically going to reflect their design needs. Cool. And then what we're going to do in the industrial sites, this is the first step for us as industrial engineers. We're going to actually consume that EBOM in what we call a manufacture bill of materials or a construction bill of materials. So what we're basically going to do is break up that tree to make sense for us as manufacturing engineers. We do this through drag and drop, and the gist with this is we want to understand how many assemblies and sub-assemblies are there, what's going to be make or buy, and just generally how many kits there are into this this product. And then similar to the MBOM, we then do industrial process sequencing. So this is very, very visual, like the MBOM, like you saw before. You could see the product, so it's nice to see it being dragged and drop and see what's contained within each sequence and each kit. For this, we fully consume the MBOM, so we use all that information again in our process sequencing. Here we can add parallel activities, linear activities, and what we're really trying to do in the context of this is say, what order are we going to do things? What do we think we need to do on, and this can either be very high level, as in we're going to do all the structure, then all the roof sections, and all the MEP, or it can be super granular down to let's install these fasteners followed by these fasteners and then bring in this beam. And we can start to level out that process as well, like you can see on screen here, to see what's efficient and what's not efficient. And for free with this as well, we'll get out a Gantt chart, to help with process planning. if we go to the next slide, we'll see, we can kind of get a little image of that Gantt chart on the top right. This is like a traditional form of planning, I guess. But the really cool thing we do get out of this is an amazing 4D build-up. So this is, like say, just off the bat of everything you've done because you've consumed 3D data. From the MBOM to the process, we now see that build-up. But the thing here, which I always like to say, is it's kind of built by fairies. This thing is built by magic. The panels just appear, the products just appear, the beams just appear. So there's no real resource that's performing it. And in real life, this wouldn't just happen like that. There would be people, there'd be robots, there'd be telehandlers, equipment doing this. So Ed's going to run us through that in a second. Just before I hand over to Ed, so I'll give one final note on this, is the really important thing with this 4D buildup and everything you'll see that Ed's going to show is this has been directly taken from design data in the EBOM to our MBOM. So if our design changes, we can see that very quickly in our MBOM. And that's being carried forward into our process sequencing to give us this 4D buildup. And then this will be carried forward into everything Ed's going to show you as well. So this means if we have changes in our product, we can react to this in the factory very quickly and very efficiently as well. So yeah, if we go to the next one, we'll I'm going to hand over to Ed now. He's going to run you through some awesome stuff on the plant layout and everything. So yeah.
Excellent. Thank you very much then, James. So effectively, as James quite rightly said, our product has been built by fairies, like we saw in the product build-up up until this point. We've had two proposals for some plant layouts. Like we can see on our left, we have a fixed sort of cellular layout where our product is effectively stationary in one work cell, although this requires people, tools and equipment to move around the product to where the work is required. Or we've also got our production line layout, which we can see, which is made up of multiple stations where the product flows between each of the different work areas, and the people, tools and equipment are fixed within each specific station as to where a particular package of the work is required. And so, with rate and efficiency in mind, we've decided to go with our production line layout, where what we can see is this is made up of 4 key work cells. So we've got basically our structural cell effectively here with our build-up of our product structure. We've also got a station for our architecture, where things like our walls, our windows, our plasterboard and our panels are being fitted, like we can see here. We've then got a third station where our MEP, including our HVAC, electrical and plumbing, gets installed. And finally, we can see that on the fourth station is where our roof gets fitted, plus the damp proofing, like we just saw there. And this is effectively the finished state of the product, which will be delivered to the customer on site. Okay, so we looked at a few options. Two of the kind of options which were proposed was to either make the beams in-house, which would involve cutting these to length on a machine, and then we also looked at another option of buying the beams in from a supplier. Of course, we can see that there are pros and cons with both, being that you get greater control over the process and can respond rapidly to sudden changes in production by making the beams in-house. Although, of course, on a few drawbacks is that you get the higher kind of recurring costs and non-recurring costs, so to speak, associated with that. But then we also want to have a look at the option of buying beams from a supplier for risk mitigation, basically looking at reducing our inventory levels, although the downside is we may have issues with supply chain which could cause interruptions to production. And so, starting off with our make scenario, effectively we've modelled up what we think that our work cell we would look like in order to basically meet our rate of 200 a day in order to keep productivity on the production line. We're also assuming a shift pattern here of Monday to Friday from 8 until 5 in the evening with an hour for lunch. We're going to have 4 crew members which are manning the cell, which will be the machine operator, a crane banksman, a repair engineer, and also someone to transport the finished offcuts. And this will also involve an NC cutting machine and a crane for loading the cell effectively. And so, in order to look at our rate capability, we're going to run a simple scenario here where we can see we can also assess kind of how products will move within our cell. We can look at offcuts as well, so we can see that one operator is discarding of waste offcuts which are produced, while the other operator is sorting the useful offcuts, so we can track things like our environmental impact, how to improve return on investment, and quite simply just by clicking on these resources we're getting real-time data from production. And so what we can see is the crane kinematics. We can make kind of assumptions and decisions on supplier selection and how the whole system will perform based on how much the crane is utilized, traveling, loaded, unloaded, loading or unloading, or empty, like you can see. We've just had a call that there's been a breakdown on the NC machine, so we've had a repair engineer which has repaired our NC machine and fixed it, and so we've now reached the end of our shift. So we can see that we've hit our rate of 200 in a day, which is great, although we need to produce 200 each and every day of the week. And we have had new information from our team that there will be basically some new complexities, including a 4-hour maintenance set of downtime, which will be required once a week in order to reset and repair all of the machinery and the lifting equipment. And we've also had news that some of our cuts are likely to have defects, and as a result they are likely not to conform, which will cause us to fail to meet our demand. And so if we just move on to another scenario which we have simulated using 2 NC machines as opposed to 1, which can basically work in parallel, you can see that we've almost doubled our output in a week of 1,710, and as basically as a bit of an offshoot of this, we've also increased our utilization on our crane system, which has improved our return on investment effectively, making this look like a more popular solution. And this now takes into account that maintenance and those extra complexities. And so if we now have a look at our results, if we now look at our observations, and so in a week we were only actually able to produce an output of 900 cut lengths because of the 4-hour maintenance period, which meant that we fell short. And this also doesn't consider non-conformance in the production process. We can also see that our crane system utilization was lower at approximately 15% in this shift, although with the introduction of another NC machine we've exceeded the weekly requirement and just shy of doubled our output. We've also taken into account failure repair times and maintenance, and this also allows for our rejection rate of approximately 10% and enabled us to improve productivity that way. Okay, so now if we now have a look at our other option, which is buying beams in from our supplier. So effectively the idea with this is that in total we've got a requirement of 6 entire modules which need to be finished, delivered to the construction site for the customer in a week. We're using the same 40-hour shift pattern for the plant, and we're expecting 2 beam deliveries a day from the supplier. So how does our production system look? We've also made a decision that our top and bottom frames are to be assembled in parallel, and our stud walls and windows are pre-assembled off the line, as these were known from previous knowledge to be particularly time-consuming tasks. And so we're going to hit go on our simulation for a week. We can see that our shift has started. We've got our bottom frame building up there along with our top frame in parallel, which are then assembled together with our vertical columns and our joists, which we can see here, our beams which are being counted on the live graph. We can also look here at our bottlenecks. We're simulating our overall system utilization in total. We know that our architecture station is kind of taking slightly longer, so you can see that we have moved some of our assembly off the line to produce the build-up of our plasterboard and our stud walls. Although, since we can see here that there's still a really big bottleneck on our architecture station, it's causing problems with excess inventory, and so if we move across to our goods in area, we can see how fast our products are being consumed. Another issue observed that the MEP currently can't actually be fitted easily once the suspended ceiling has gone in, so we need to review the process on that. So just kind of looking to the general view on a high level, we've just had a look at our calendar view of basically everything which is happening, which is color coded against time along the horizontal on each of our stations. We've ended our simulation and managed to produce an output like you can see so. So if we go into our report, we have produced 6 modules which has met our requirement, and we can see that we can also show this report to our stakeholders, which has got all of the data for our rate, bottlenecks, efficiency and abnormalities. Although what we actually want to decide is that although we've met the demand of 6, 1 or 2 of those units are going to show signs of damage and so have to go for rework before they are then delivered to the customer site. And so effectively what we're going to do is we need to review our process anyway, because it flagged up lots of problems, and so that's what we're going to do in this next step. Okay, so like we found out in the simulation that we've just run on our initial factory performance, we noticed that there were some issues, one concern around the DFMA and worker safety aspect around one of the operations, which was effectively the MEP install, like we can see here. And so what we've done is we've effectively had a look at one of the operations where with the suspended ceiling already in, then the MEP would need to be installed at height due to poor access. Although we can then have a look at this in more detail because we've identified this early on in the design stage. We're going to simulate how this will be installed on site on the construction, and we can then hone back down and look at details within our factory, including using the ergonomic toolset, which is specialist toolset within DELMIA. Okay, and so following those improvements, we've also taken out the suspended ceiling and moved it onto the final station, like we can see here. And so now the way it flows is that only the walls and windows will be fitted at the architecture station, like we can see here. And this eliminates the need for working at height and improves on ergonomics. We're just going to skip through our shifts on our calendar view there, and now we can see that actually by moving that workload off the architecture station, we've outputted 10 finished modules, which has not only accounted for the 1 or 2 damaged modules needing rework, but it's also shown that the system is capable of responding rapidly and meeting ramp-ups in demand or changing product complexity. Okay, and so just some observations on that. just having a look, and so we determined that by doing our bottom and top frame assembly in parallel prior to the main structural assembly, we streamlined production. We've also noticed that before we balanced the line, there were idle times and delays to shipping finished units to the customer due to the bottleneck on the architecture workstation, which we can see. And there was also this issue with worker safety and DFMA when fitting the MEP once the suspended ceiling had already been installed. And we determined that although we've met the customer demand of 6 units in a week, we'd fail to meet that demand if we take into account rework which needs to be done before the modules are delivered to site. And so in the second scenario, we managed to output 10 modules within the time frame, within a week. We've relieved the workload on the bottleneck and moved some of the work off the architecture station onto a less utilised station, being the same as the roof for the ceiling fit out. And we've reduced idle times effectively from easing of this bottleneck and streamlined the production. We also resolved the issue with installing MEP prior to the ceiling fit out, and we've eliminated the need for working at height. Although we want to do further investigations into postural analysis and details on further worker safety in our out of the box, off the shelf functionality within DELMIA ergonomics. And we've also determined that we've exceeded our demand of 6 in a week, allowing for rework and changes in production. And so, if we just go on to the conclusion, just to recap on our goal from the start, we were asked to assess the industrialization effectively, and we've done this by creating manufacture bill of material breakdown in our MBOM, where this has enabled us to understand better our make or buy opportunities. We also created process sequencing and reviewed the build-up of how the product will be built once it is in the factory, and along with an early plant layout. We then used factory flow to assess how many stations we need, where are the bottlenecks, and what is the efficiency. And to finish off, we've also simulated what we call optioneering in the factory, because you're always going to have multiple solutions to a problem. And just to go back to what James said at the start, of course, the big value point here that we're using real data digitally to drive those optioneering decisions. And so with that, I'd like to say thank you very much. That's all the technical points covered, and I'd like to hand back over to James. Thank you very much.
Great. Thank you very much, Ed. That was super, super interesting. Thank you. Cool. So if we move on to the next slide, if that's okay, Ed. Great. Thank you. So next up, so this was, hopefully you agree, that was super interesting from Ed, and we've done some amazing assessments on the factory here, all digitally, and found loads of value, exactly as Ed said. So just to highlight, if you've enjoyed this session, next week on the 2nd of May at 1 p.m, which is Tuesday, what we're going to be doing is we're going to take Ed's product and we're actually going to simulate the installation of that on site. Once we've found that out on site, like if it works or doesn't work, have to join the session to find out. We'll then come back to the factory and see if there's any improvements they found, how that affects the factory. We'll also be doing some other simulations on a walling product, a dryline wall product, where we'll simulate that in the field, a traditional install, and you'll see some of the benefits you can get out of that, such as worker safety. And then we'll have a look at a micro factory to improve that, and finish off with installing that new prefab product in the field again. And if you absolutely loved all of these sessions and you can't get enough of us, please do come join us at Digital Construction Week on the 17th and 18th of May in London. We'd love to see you there. And then if you've want to also get your hands on this tool straight away and start using it, and you can already see some benefit for you as a business, please get in touch with us. We currently have a 3-month cloud promotion where you can have all of the tools we've shown here and some more, to be honest, for just £500 for 3 months, and there's no commitment required. So past that, there's no commitment, but it's because we know you'll love it and you'll carry on using it once you've gotten started. So and just to reiterate on that same point, so ProdTechs are a reseller, so we can sell all of the licenses for everything you've seen in today's session. We also offer expert training from experts such as Ed and myself and other colleagues that you'll see in these series, where you can get first-hand training from people using this tool every single day in the field, which is awesome, really exciting. And yeah, I think that's about it for today. So yeah, thank you again for joining. We hope you enjoyed it, and I think we have some time for questions now. So yeah, back over to you, Ricky. Thank you.
Thank you, James. I'll just take control of the screen here. Hopefully you guys can see my screen again now. Yeah, so thank you very much for that, guys. I think that was a really good session, really interesting content there. So thanks for taking the time to put that together for everyone. Hopefully everyone in the chat enjoyed it. We've had some really good questions coming through already, but if you have any other questions you want to ask, put them in the chat and we'll try and get through as many as we can in the time we've got. So yeah, let's get started on these questions because I want to try and get through them all. So the first one we've got is from Abdul, and he's asking, can we use any third-party CAD software to import data? Maybe this is a good one for James. What do you think, James?
Yeah, sure. So great question. So yeah, so we can use a whole host of different third-party softwares if you have data coming from different areas. So quite often your supplier is not going to use the same software as you. They might not be using 3D Experience DELMIA. So the beauty with 3D Experience is it's built load of connectors, loads of converters. So pretty much no matter what your suppliers are using, I'd be pretty confident to hedge my bets we could bring it in. And there's some really clever stuff as well we can do where sometimes we can just bring the data in and just drop it in. And other times we can actually connect to whatever their different software packages as well. So we can almost see like live updates as well, if your suppliers want that. important point. So yeah.
Brilliant. Thank you, James. So one more question we've got here, and this is from David, and he's asking, how do you deal with the simulation of new manufacturing or assembly processes without process windows, studies, and historical data? So yeah, who wants to take this one?
Great question again.
Question. Yeah. I don't mind, James.
Yeah, sure. So again, really good question. A really common scenario that we've seen with loads of different customers of if you have a new product, you might have no data because it's the first time you've ever built this thing, right? Sometimes the product itself might not even be that mature, so even we don't know what the finished thing is there. What we can do is we can start by building up this, taking you through every single thing we showed you in this webinar today. And there'll be lots of gaps where you don't know it. The whole point is if people have different ideas of how to solve it, or if there's a solution already existing in the market for how to solve it, we can bring in that solution, simulate it, see if it's going to meet your business needs, such as cost, environmental impact, resource. Quite a common one is space. There might be an existing solution, but it's huge and doesn't fit in your factory if you have a small facility. So it's no problem if you don't have data. The whole point of this is it's like a tool to take you on that journey. So if you have data, great, you can go straight into the optimization stages. Fantastic. If you don't have any data, use it as a tool to build that data digitally rather than build something physically and invest loads of money and find it doesn't work. Or, sorry, isn't it optimal?
I think if I may just add on, just kind of building on what James was saying, if I may also, that what we showed was very much 3D. It's very much visual in our tool factory flow simulation and showing our plant layout design. It might well be there might be a scenario where you don't actually know what your factory for your offsite prefab construction is going to look like, and so there are also other workbenches within DELMIA, like process flow simulation, for example, which takes more of the form of the tile view, which you saw in the process planning kind of characteristic of that in MBOM. And this might be, for example, if you don't know about your resource view, you don't know about how big your factory is going to be, but you want a very quick answer on rate and how your deliveries are going to work, for example. Just thought I'd sort of add on that point. Hopefully that kind of answers it.
Yeah, great answer, guys. Well done. So on to the next question then. I'll try and rattle through these. So the next one is, how do we identify each structure based on project? Can we put tag numbers or RFIDs on them? So yeah, I guess this one's open to a bit of interpretation there in terms of exactly. I mean, if you're thinking about like tracking your physical products and linking that in with the digital virtual side of it, then yeah, that's kind of a little bit outside of the scope of what we were showing today, obviously, but there's ways to do that. So there's a package available called Aprizo, and that basically can act as like your MES system and can allow you to basically integrate the physical real world with the virtual to bring those two data sets together and provide a lot of extra value in there. It's kind of like it's a whole another package with a huge amount of capabilities in there, and I think we probably need a whole another series of webinars to really dig into the details of that. But if that's something you're interested in, by all means, get in touch with us and we can schedule a session to dive into a lot more detail on that side of it. I guess maybe the other way you could look at the question is if we're creating like the factory flow simulation of a product that's being delivered to a number of different customers, or how do we track individual elements of that product through the factory flow if we want to track a percentage that I don't know, if you're making like a product and a percentage of them are going to one modular housing company and a percentage of them are going to a different company, how do you track that? And I guess that's maybe a bit more of one that Ed could enlighten us on, perhaps. I don't know, Ed.
Yeah, so just kind of on a bit of a technical note with that, there is the functionality within tool sets including factory flow where you can change the mode to say, for example, group based, where you've got groups of products which are routed in different directions, or you might decide that you want, actually, rather than a fixed layout or a production line, you might want kind of like a combination, like a combined layout where you've got different product routings for variants A, B and C, for example. And there is also the functionality just kind of thinking about tracking within factory flow to also do you can sort of add in sensors on things, and you can simulate that in virtual.
Great. No, thank you, Ed. I'm conscious we're running over on time here, so I'll try and make this just one more question now, and if we didn't get a chance to answer your question, we'll follow up on email with you if we've missed any, and if we've misinterpreted the point of your question on any of these, please chase us up and we'd love to chat in a bit more detail about it. So one last question here is, do you have experience in design to fabrication in timber construction and the control of machines with the BTLX format? Are there alternative post-processors for, e.g., Feynman, HOMAG, etc.? Yeah, so I don't know, what do you guys think about that? Is that something you've come across previously?
Very good question. Let me just read that one more time. Yeah, so to answer the first part, yes, we've done some stuff with timber in the past. So yeah, so it's kind of the similar process for running through that of everything you've seen here, plant layout, process, everything. Oh, sorry.
Yeah, I think the thing with with this good with this solution is basically the process is the same regardless of how you're actually manufacturing or what materials you're using. It's the details of that process that will change, and some elements of it, right, that'll be adjusted to suit, you know, the product or the materials or whatnot, right?
Yeah, sorry about that. Someone came into the room to try and end the webinar earlier or something. But yeah, apologies, I missed what you said as well, Ricky. So yeah, and
No
I think post processors, yes, you can definitely do that sort of stuff with 3D Experience as well. So you can build in what's called virtual commissioning, where it's something we've done with a lot of machining in automotive and aerospace that we're starting to, if it's needed, we've seen it transition to construction. Where you can virtually build those machines, you can program them. Yeah, you could do all that in there as well. It's the main thing is just if there's a real business need to do that. So yeah, but yeah, if
exactly.
might be an interesting one to follow up on as well, Alexander. If
Again, yeah, exactly. It's not. I don't think it's something that we've got planned to dive into too deeply in this webinar series in terms of
no.
you know, control of NC machines or robots or that kind of thing on the virtual commissioning side. But we do have some good demos available from other projects we've done.
Yes.
And if it's something that's you know, something that you're really interested in or want to focus on, then you know, we'd be happy to have a specific session, you know, to run through some of that. So please reach out to us.
I'd encourage you to check out our Prodtex AS Vimeo page as well. We have some great examples of machines where we've done all that commissioning stuff on it. It's be a nice inspiration in there too.
Yeah, that's a good idea. Maybe I'll share a link to one of those videos with everyone in the follow-up email.
Cool.
Fantastic. Well, I think that's pretty much all the time we've got. We've gone a bit over there. Hopefully you guys don't mind too much. But yeah, thank you so much to everyone who took the time to attend this webinar. Hopefully it was of benefit to you and you got some value out of it. I know, you know, we enjoyed putting it together and creating these demos, and yeah, we look forward to hearing a lot more from you guys and seeing you at the next session. So our next webinar is taking place on Tuesday, and I'll send up a follow-up email with a link to register for that and some of the other things we talked about in this session. And look forward to seeing you all at the next one, and hopefully at Digital Construction Week. Thanks again, Ed and James.
Thank you very much for hosting.
Thanks everyone for joining. Thanks for taking the time.
Thank you.
Right. Thanks a lot. Have a good afternoon.